In this tutorial, we are going to disassemble and see what is inside a Siemens S7 300 series PLC. To disassemble this PLC, I'm going to use this tweezer. To disassemble it, it is simple. These are plastic locks. There are 3 locks in each side of the PLC, not on these 2 sides, only the top and bottom. We are going to open these locks using this tweezer. Alright, I'm going to put this tweezer between these 2. Okay, like that. Open the lock, and I'm going to pull the top part out. I'm going to do the same. Alright. Alright, like that you can pull the top part out. To remove the boards, you can simply remove them. Alright, you can pull these 2 boards together. If it is hard to remove the 4 screws, remove the metal plate, then remove the power board. Alright, just pull it, wiggle it, and pull it out. You have 3 locks, plastic locks, here, and bottom here. You have to push them. Alright, or you can use a flat screwdriver and pull them and pull it out. Alright, that's how you disassemble. Alright, to remove the terminal set from the PLC, this is the screw. I'm going to use this flat screwdriver and unscrew this screw at the middle. Pull out so you can see the locks on both sides. You can also disassemble this one, and you can clean the terminals inside this terminal block. Alright, as you can see on the motherboard, there is a lot of dust. If there is dust like this, you have to clean it, but make sure not to touch this component with your bare hands. Use anti-static gloves, wear anti-static bracelet while handling these PCBs. This is the digital input card of the S7 300 PLC we just disassembled. As you can see, these are the ports that connects to the input terminal block. Alright, if you look at this circuit, you can see resistors, SMD resistors in series. This pin of this resistor is connected to the input pin, so input supply voltage. So it goes through these resistors At the end resistor is connected to the LED at the other side. They took outputs from different locations of this voltage divider arrangement. That's how they took inputs for these ICs as well. Alright, talking about the ICs, as you can see, these 4 ICs are quad comparators, which means there are 4 comparators inside these ICs. Each one of these ICs will compare 4 inputs from these input pins, and it compare that voltage to a reference voltage. Once the voltage at these input pins exceeds certain voltage level, output of the comparator changes. That output was given to this IC. This is the 8-bit parallel in serial out IC, but only 4 bits being used. As you can see, we have 4 comparator ICs, plus we have 2. Again, here we have 2 parallel in serial out ICs. These are the optocoupled ICs. These optocouplers separate the motherboard side of the PLC. These are single optocoupled ICs which have NAND output. This one connects to the output, serial output of this parallel in serial out IC. So on, this one connects to another parallel in serial out IC. So on, these 4 being used for that purpose. And this one is the clock signal that coming from the motherboard that require for this parallel in serial out ICs to shift the serial data towards these optocouplers. Input voltage 24 volts coming through here, and it goes through this resistor, and then this diode. After that, this coil, assembly coil, to the input of this 7805 regulator, 5 volt output. This regulator supplies the power to the ICs and the components. Alright, this is the output card of the PLC base module. You can see we have 2 separate sections which have separate components for each side. These are the ports that connects to the output terminal of the PLC. If you look at the first pin on this terminal, you can see it goes through this assembly fuse on each section. If you have output section that doesn't work on a PLC, it might be due to a blown out fuse. As you can see, we have 2 separate sections. These are the 8 pins. These are the 8 output pins on each side, which directly connects to the outputs of these ICs. This IC is a high-side switching IC, which is a switching IC which can deliver up to 0.6 ampere output. The reason to use these ICs is that the microcontroller or the microprocessor inside the motherboard cannot deliver that much current through their output pins. Inside these ICs, there is an array of FPDs connected to these output pins. These ICs have short circuit protection, ESD protection, all current and thermal protection. Depending on the input logic levels available, it will turn the FPDs on or off, which turn the outputs on or off. This is the port that connects to the motherboard or the main board of the PLC. You can see this IC, which is available for this side also. We have 2 of these ICs. These are shift register ICs, 74HC595. These ICs, the serial data coming through this port shifted to the output pins of this IC. This is technically a serial to parallel IC that shifted logic levels are available at the output pins of this IC, which is connected to these optocouplers. These are dual optocoupler ICs, which means they have two optocouplers inside them. So each IC have two. We have 4 here, which means 8 optocouplers. The outputs or the transistor side of these optocouplers are connected to the inputs of these switching ICs. So that's the signal part of this circuit. You can see some other components as well. The LEDs in this case are directly connected to the output pins through these resistors, which will turn on or off, depends on the logic level at the output pin. First, start with the power circuit. As you can see, this is the power input port. You can see the fuse behind it. This coil is the switching coil of this switching regulator IC. We have several switching regulator ICs. This one and this one also a switching regulator IC. If you turn this board around, you can see a switching regulator IC here. Also, we have a linear regulator IC here, LM317. There are also a regulator IC here. These are the components of the power circuit. These are not regulator ICs, these are transistors. You can also see the eject mechanism of the memory card here. Alright, if you look at here, we have the switch, run, stop, and reset. This switch have two mechanical functions. This between start and stop, we have toggle switch, and between stop and reset, we have a momentarily switch. Alright, these are the optocoupler ICs. Just isolate the motherboard side from this board side. Alright, let's talk about the communication ports. This one is the DP port. This one is the MPI port. These two ICs are trans-receiver ICs, which change the voltage levels of the signals. This IC is a transform driver for RS485 protocol or interface. You can see the transformer here. It provides the isolated power for the ports. These are the things you can find on this power plus the interface board. Alright, this is the main board of this PLC. You can see the microprocessor here. You can see the oscillator of this microprocessor, and this one is the real-time clock IC. This is the oscillator of that clock IC. This is the port that connects to the output card. This is the port that connects the input card to this main board. This is the RAM IC. This one is 16 megabyte RAM, and this one is the ROM IC. This one is 32 megabyte. If you look at here, these are bus buffer ICs. You can see them throughout the board. This one is an octa buffer IC. This one is a quad buffer IC. When there is a port or expansion port, you can see these buffer ICs. If you look at here, this buffer IC is for the output card. This buffer IC for the input card. You can see there's a 1117 linear regulator adjustable, and also you can see this switching regulator IC class the components. If you like this video, please leave a like. If you like PLC related tutorials, subscribe to this channel. More videos to come. Thank you for watching. See you in another tutorial. I'm Sima for learnitstepbystep.com.